Good morning, grade 10s, and welcome back from the weekend. I hope you had a good one, and I hope you're ready to jump straight back into trigonometry. Another really easy concept to go over today, and it goes hand in hand with Friday's concept because it is also calculator work. Once again, we are going to be using our sine, cosine, and tan buttons on our calculator. The only difference is that today we are looking for an angle, theta, x, y, beta. It can be any angle. It may even have a number in front of it. We may be looking for 2x or 3 theta. Whereas on Friday we were given the degree, we were given the angle, and we were looking for the ratio. Today we're given what the sine of that angle or tangent of that angle or cosine of that angle is equal to, and now we're required to use our calculator to find that angle. And it's absolutely incredible that at least our calculators can help us do this. So let's have a look. If we are asked to find theta correct to 1 decimal place, if sine theta is a half, now you can't go and plug a half into the normal sine theta function on your calculator, because then you are presuming that a half is the angle, is the degree. But here we don't see a degree sign. We are actually looking to write our final answer with a degree sign. So you have to use what we call the inverse function. Now that inverse function, you'll have a look. You can't really see it on this slide, but if you press shift and if you look above the sine, cosine, and tangent buttons on your calculator, you'll see it's written as sine to the power of -1. Now that to the power of -1 is not an exponent. It is a mere notation to tell you that we are using the arc sine, also known as the inverse function of sine. We aren't raising it to the power of 1. We're not taking it underneath a 1 and putting it in fraction form. We are inversing the process of getting the ratio y. We are telling our calculator to tell us what would the angle be if the ratio is given to us, and in this case the ratio is a half. So what you need to do is press shift on your calculator and then press sine and then insert the half ratio, just as I have presented now. So theta is going to equal shift sine, arc sine, a half, and then once you press equal, you'll see that theta equals 30 degrees. Now, the next, please don't forget to write the degree symbol in your final answer, since we have found the size of an angle. The next example, number 2, requires us to find theta again, but here it's made it one little tiny incy-wincy bit more complicated. That big fat 2 is merely a coefficient in front of that trigonometric function called tangent. So if we want tangent all by itself, we treat it like algebra and we divide by 2 on both sides. That will cancel out the 2 on the left hand side, and we'll end up with tan theta equals a half. Now that we have tan and an angle all by itself, note the angle could have a number in front of it. It could have been tan 2 theta, but we are ready to use the calculator when there is no number in front of tan. So now we have tan theta equals a half, so we can press shift on our calculator and we'll get the arctan function, pop in a half, and then you can press equals and you'll get your answer in degrees. And voila, we've got theta equals 26 degrees. Okie doke, so example number 3 is a similar concept to question number 2, where we need to get that tan and its angle. Now, what is its angle in this case? The angle is 2 theta. So all we need on the left-hand side of the equation is tan 2 theta to be all by itself, and then we'll be ready to use our calculator. So If we remember normal solving equations, to get an x all on its own, if it's being divided, we're going to multiply by 2 on both sides. So tan 2 theta is going to be 5,102 times 2, which gives us 10,204. Now, because there's no coefficient in front of tan, or it's no longer being divided by anything, we can now whip out our calculator and press Shift tan. Into your brackets, insert 10,204, and now when you press equals, we've got what 2 theta is equal to. So 2 theta equals 84,4 degrees. Please do not forget degrees. All right, you will lose a mark if you do not insert that degree symbol. Also, remember, the question asked us to solve for theta. It didn't ask us to solve for 2 theta. So now that we have 2 theta all by itself and there's no longer a trig function to worry about, we can now divide by 2 on both sides, leaving theta alone to be equal to 42,2 degrees. Please remember that if you're not following these examples, you are more than welcome to tell your teacher the exact moment of this video where you feel lost, and we will gladly re-explain. Another thing I'd like you to please note is that your calculator mode needs to be in degrees. Sometimes it uses another format in which one can measure angles, and that format is called radians. And if it's not in the degree mode, you'll be getting different answers to this example. So if you please, can you work with me throughout this video, use your calculator to make sure that your calculator is giving you the same figures as on the screen. If it's different, please reach out to your teacher so that we can tell you how to put your calculator into degree mode. Okay, now for the last example. Here we've got quite a bit going on, but we treat it as a normal equation until we have sine and its degree and its angle all on its own. Now, what is its angle? In this question, the angle is theta minus 10 degrees. So we just want to get theta minus 10 degrees all on its own, and we'll be ready to use our calculator then. So you can either see that the coefficient of sine at this stage is actually 2 over 3. So you can divide straight up both sides by 2 over 3. I know that's how Mrs. Townsend does it. She likes to get rid of everything in one go. Or you can take 2 steps and first multiply by 3. That's the most natural to me. I times by 3, and now I've got 2 sine and its angle equals 0,306 because I times by 3 on both sides. And then in the next step, you can divide by 2. But if you divided both sides by 2/3 straight up, perfectly fine. You'll get the same answer. Then, now we've got sine and its angle. Perfect, all on its own. So let's whip out the calculator and press shift sine, and then we're going to get theta minus 10 degrees all by itself. The calculator will do the thinking for us, and it will tell us that theta minus 10 is 8,8 degrees. Also note that the question asked us to round off to 1 decimal place, so that's exactly what I've done. Now I want theta all by itself, so I kick over the 10, it becomes a positive 10, and we add it to the 8,8 to make a total of 18,8 degrees. Chuff, chuff. It's as easy as that. Good luck for your homework. Do the entire exercise. It will be quick and easy, and check the memo. Check that you get the same answers as the memo, and enjoy. See you tomorrow. Oh, never mind. A quick recap of how to use the calculator. There's always 2 situations. One, if you are given an angle and you're looking for a ratio. So that was Friday's work, the exercise before today's homework activity. If you are given an angle and you're looking for a ratio, it's super straightforward. You just plug everything as you see it in the question into your calculator, and you get your answer, and your answer is a ratio, so you don't need to use the degree symbol. Then, if you are given a ratio and you're looking for an angle, that's when you need to make sure that tan, sine, or cos is by itself with that angle. So you use algebra, you use inverse operations. If it's been times by something, you divide, etc., etc. Then you can press shift on your calculator to get the final answer as an angle. So don't forget the degree symbol.